Hi there, I'm Mr. Moskaluk, and I've been teaching chemistry for a lot of years. The video you're about to watch is just one of many that I've recorded to help students learn chemistry.
Here we have a problem using Avogadro's number and atomic mass in moles. It gives you a nice idea of what's happening with moles and grams, and also numbers of atoms, of course. The question asks about the average mass of a helium atom in grams. In other words, how many grams does the mass of an atom weigh? And atoms, we're going to pick our helium. And if we look up helium on our AP Chemistry periodic table, here we'll pull up from resources and we'll look at helium, and we see here that the average weight of helium to three significant digits is 4.00. This can be used as grams if you have a mole of this, or also as Daltons. It'll work both ways. So let's get back to our problem. Here's our problem again. We know that there are 4 grams in 1 mole from the periodic table. And we also know that there are 6 times 10 to the 23 atoms, or any type of particle, in 1 mole. So if we want to find out how much in terms of grams we have for just one atom, we'll just do a little division, and I'll get my calculator out. Here it is. I'll take my 4 grams per mole and divide it by the Avogadro number, which tells you how many of those little atoms are going to be present in that 1 mole. Now, get this, times 10 to the 23. There are a lot of atoms in these 4 grams. This is going to be 22 zeros and then a 6. So we're going to get a small number in terms of grams. And there's our answer, and it matches what we expect here to 3 significant digits, 6.64 times 10 to the 24, negative 24. This has got to be a small number, grams. This one would be wrong because this would be a huge mass. One of the things you should think about when you're using scientific notation in your calculator is, does the answer make sense? This is how many grams an atom is, and we're not going to have many. So this negative 24, the decimal point, and 23 zeros would be really a small mass, less than you can measure. Now, a quick thing while we're dealing with this. This is the average mass. When you have a bunch of helium here on Earth, let me get to helium again. It is a mixture of a couple of different isotopes which are stable. There's helium-4, which is the more common one. In fact, here, let me get that again, and you'll see that it ends up having 2 protons and 2 neutrons, and it's 99.999998% present on Earth. Now, there's a little bit of variation, and because there is some helium-3 where we still have 2 protons but only 1 neutron. And as you can see, it's a really small percentage here on Earth. But if you were to go some other places, like a star or whatever, you'll find a little bit more of this. Most of our helium comes from decay of various rocks, and that produces this helium-4. But we get some helium-3 if you have some nuclear reactions. In fact, I have a little bit of tritium in a keychain that I have that's gradually changing into helium-3. But let's go back and try one other thing just to move this through. You can look up a mass. This is Daltons, and 1 Dalton is 10 to the negative 24 grams. Very, very small mass in grams. And our helium, as I said, is either 4 grams per mole or 4 Daltons. So I'll put a 4 there, and that matches our answer that we had. Our answer was 6.64 times 10 to the 23. Now their answer is a little bit smaller, but that's because we only had this to 3 significant digits. Well, there's our answer, finding the mass of a helium atom. It makes sense. Now, if we use other atoms, we would just take whatever the atomic mass is and divide it by 6.02 times 10 to the 23. Okay, that wraps it up.